All right, these are the answers to the review for our test here. The first one says, what does a to the 6 equal for this sequence? So it really is just about putting 6 in. We should get 6 minus 1, that's 5 factorial, over 6 plus 1, 7, to the 6 minus 2, 4th power. Okay. Now you don't have to work that out, but if you did, it'd be 120 over whatever 7 to the 4th is. Okay. Number 2 says, write a general expression for this. So at first it can be a little confusing because it doesn't, maybe the sequence or the pattern doesn't show itself, but you kind of see that you have square root of 3, square root of 5, square root of 6, square root of 7. So if you kind of look here and try to rewrite it as what it could have been, square root of 4 seems to fit that pattern on the top, right? Square root of 4 is 2, and to get 1, we would have a 2 on the bottom. So if you did square root of 4 over 2, that would be 1, and that would kind of fit what's going on here, right? So if this is n equal 1, and this is n equal 2, and n equal 3, and so on, then a sub n is equal to, on the top, the square root of n plus 2, just take whatever n value are, plus 2 more, and you get what's going on there, okay? And on the bottom, we've got 1, 2, 6, 24, 120. This is times 2, times 3, times 4, times 5. That's n factorial then. And hopefully by now we kind of recognize that. Same thing on number 3. I want to see this sequence. I see on the top I've got 4, 5, 7, 8. Boy, if that was a 6, that would make some sense. And if this was a 3, that would make some sense. And then if I kind of treat those as 3, 4, 5, 6, 7, 8 and say, well, let me rewrite this. 1 then would be 3 over 3. And to get 2 up to 6, I multiply by 3. So if I multiply this by 3, I get 81. Now I can start to see a little clearer what's going on. The top, 3, 4, 5, 6, 7, 8, if this is n equal 1, n equal 2, n equal 3, the top is just n plus 2 more. Okay. The bottom is 3 to the nth power. 3 to the first, 3 squared, 3 to the third, 3 to the fourth, and so on. All right, so that's my general term for this. All right. Now this is going on forever and ever. So this is a sigma sum n equal 1 to infinity. And then it says, does this converge or diverge? Well, since I have a polynomial over an exponential will dominate over time. And so I would say that this converges by just looking at it. But then if I had to go further and actually prove that, I would probably prove this by using ratio test. Right. But we won't get into that yet. We'll get to that in just a second. 4 says, can you give an example of something, an alternating geometric series that converges? That's easy enough. Just pick something that has a negative in it. You can have the negative outside, or you can have it inside with the geometric. Just make sure your R value is something between, -1 and 1. So that right there would alternate and converge. Like I said, you could, if you wanted to, let the alternator stand out here. All right, and then make your geometric series be something similar, like 3/5 to the end, or maybe even have it be like this, where now really the ratio is 1/4 to the end. So there's just 2 options. There's many other ones that you could do. As long as it has a negative to the nth power or something like that, that'll make it alternating, and then the geometric is the common ratio. All right, a series that diverges, but the terms of the sequence converge. So that, again, there's lots of options there. Anything that has, say, like 2n squared plus 3 over 5n squared minus 1. If we let this go, this is going to converge to 2/5 as a sequence, but then that means we'll be adding 2/5, 2/5, 2/5, 2/5, so the series will diverge. So anything that converges to a number like that, or maybe it does converge to 0, like 1 over n, the harmonic series, but we know that that also diverges. While the terms converge to 0, the series itself will get bigger and bigger and bigger. So there's 2 examples of something like that. All right, then we were asked to tell whether or not these converge or diverge and to give proper justification. So it's a good idea for you to kind of get into the habit of having a gut instinct. So when you look at this, try to determine, carefully but quickly, will this converge or diverge? So you look at this and you see 3n, 8n. Over time, that sequence is going to go to 3/8. It doesn't go to 0. So we have a good feeling that this diverges, okay? And if we had to prove this, then we would just take a look at that sequence, take the limit as n goes to infinity, and show that that limit is 3/8. And the nth term test says that if that does not go to 0 as a sequence, then you have no chance of converging. So this diverges by nth term test. Number 7 here, I'm looking at this and I see that I've got 9 to the n on the bottom. I just have 81, just nothing else but other than 81 on the top. And so this is a geometric series. The ratio is really 1/9. I could rewrite this as 81 times 1/9 to the nth power. And it's a little clearer to see that ratio. So I know this converges. Okay? And I can say it converges by geometric. And I would have to state in that the R value is 1/9. Okay. Now, not only do we know that converges, we could actually go one step further and say what it converges to. If you were to put 1 in here, you'd get 81 over 9, which is 9. That's our first term, over 1 minus the common ratio. That's 9 over 8/9. If you flip it over, it's 9 times 9/8, which is 81/8, or 10.125. That's actually what it equals out completely. That's what it converges to. Number 8, if I rewrite this, I get 5 over n to the 7/8 power. Okay, and again, right away I see this as a p series. That p is less than 1, so I know that this diverges by p series. P equals 7/8. So once I see that exponent there, right away I can go to that. This one, I don't have it, it's not a geometric, it's not a p-series, anything like that, but it certainly does look like 4 to the n, right? It really looks like 1 over 4 to the n, which converges. And because it looks so similar, I'm pretty sure this will converge, right? So if I'm in like a multiple choice part and all I'm asked is does it converge or diverge, I can kind of go with my gut instinct on that. But if I'm on the free response and I got to actually explain this a little bit, then I need to do something more. So let me look real quick. Plus 5 makes these denominators bigger, which makes these terms smaller, which means this sum is less than this. So if this converges to a value and this is less than that, then there's no way this could blow up and go to infinity. So we can say that this converges by direct comparison to 1 over 4 to the n. If that wouldn't have worked out so nicely, then I would have had to do a limit comparison, or you could have just used limit comparison from the beginning if that's your desire.